Hello, this is Martha once again from the Academic Support Center at Raritan Valley Community College. We're continuing on with our Pre-Calculus 1 final review. We're going to try and get through problems 13 through 16 within our YouTube time limit. So let's get going. So question 13 says, is the function, and it gives the function, even, odd, or neither? Show or explain your answer. So let's do a quick review of what even and odd functions are, just how to recognize them. So even functions are symmetric about the y-axis, and you know if it's even if you take your f of negative x, so wherever there's an x, you put a negative in and negate that. If you get back the original function, the original signs, you get f of x, so it's even. If it's odd, if you take f of negative x, the whole function gets negated, negative f of x. If it's neither, it's a mix. So we're going to take this, we've got this positive 4x cubed plus, so another positive 3x squared minus negative x. So when we take and we put negative x in there, we need to get the positive, positive, negative. Or if it's odd, it's going to be negative, negative, positive. So let's see what happens. 4 negative x cubed plus 3 negative x squared minus negative x. Negative, and a negative number cubed is going to be negative. Negative 1 times negative 1 times negative 1 is negative 1. So this is going to be negative 4x cubed, and we've got negative x squared, and a negative times a negative is a positive, so this sign stays the same with plus 3x squared. And we've got minus and negative x, which gives us plus x. So let's look at our signs. We've got negative, positive, positive. That's not the same as the original, so it's not even. And if it were odd, it would need to be negative, negative, positive. But this is negative, positive, positive. So we get that it's neither. All right, on to question 14. Describe the transformation of the graph f of x to the fourth for this graph. So a graph of g of x, where it's 2 minus the quantity x plus 9 to the fourth. So we're going to break this down. Oh, we can't forget to label any maximum or minimums on this graph. So our x to the fourth looks a lot like our x squared, so we're just going to draw it like that, just as a reminder of what the parent function is. And I'm going to rewrite this so it's a little bit more what we're used to seeing. The negative stays, so it's negative x plus 9 to the fourth. This 2 up front, I'm going to put plus 2. You don't have to do this. This is just what we're used to seeing, so it's a little bit more familiar. So let's break it down with each change. We've got a negative out here. So we know that this negative out connected to the x but not inside the parentheses, that rotates about reflects about x-axis. So it's going to flip like that. Now we're going to take this plus 9 that's inside our parentheses. That means that we're going to go 9 units to the left. Remember, the base is x minus something. And a plus is just minus minus. So we know that this plus 9 means move 9 units left. This last thing that we're going to worry about is this plus 2. That means that plus 2, this is a change in our y value, so it's going to move 2 units up. So let's draw this. We've got we know that it's flipped about the x-axis, so it looks like an upside down U. And we're going to go 9 to the left. We're going to say that this is 9, so -9, and it's going to go up 2. We know that our vertex is going to be at -9, comma 2, and it's going to be pointing down. So -9, comma 2 is our maximum. And this, our graph will look something like that. So to describe this transformation, we just went through each piece of what we knew was happening. And voila, there we go. Moving on to 15. So for 15, we're given this function, x plus 2 divided by x squared minus 9. We're told to find the equation of any asymptotes, find the intercepts, and we're going to sketch the function. So we're going to break this down. Up top, we have x plus 2, but in the bottom, we can factor, that's a perfect square, so x plus 2 stays the same. And this is x plus 3, x minus 3. Anytime we have a perfect square, we have x squared minus a squared. Come on, at the menu. That results in x plus a times x minus a. And that's a pattern that can really help us. And why? Because let's do any asymptotes first. Remember, we have vertical asymptotes where the denominator equals 0. In this case, the denominator equals 0 at -3 and +3. So we have vertical asymptotes at x equals -3 and +3. So that's one. Now we've got an x over an x squared, so we know that our horizontal asymptote is the x-axis, but that can be crossed. So now we're going to do our intercepts. Let's do y first. When our graph hits the y-axis, our x's are going to be equal to 0. So we put in 0 for our x's, and that gives us 0 plus 2 over 0 squared minus 9. And hey, look at that. That makes it nice and easy for us. That gives us our y-intercept at 0, -2/9. We're going to see if we can move this out of the way. Nope. Okay, we're just going to shift that down. So that's our y-intercept. Now let's do our x. Now for our x-intercept, we set everything equal to y. And if we set this equal to y, or set this equal to 0, right? We've got x plus 2 over x squared minus 9. Now if we multiply both sides by x squared minus 9, that cancels out, and it cancels out there on this side, because 0 times anything is 0. Now we just have to solve the x plus 2. We subtract 2 from each side, so we know that the y-intercept is when x equals -2. So our x-intercept is -2, 0. So let's graph. We get our x and our y-axis. Now let's draw in those asymptotes. At -3, I'm just going to draw it with some dashed lines. Then at 3, our horizontal, we don't have to worry about this one because it gets crossed. And we know that it hits, we've got an intercept at -2, 0, and -2/9 is just, I mean, it's not even -9/9, so it's just below the axis, the x-axis. So this is -2, 9, and this is 2. And because we're short on time, we're just gonna kind of talk through, you find values to see, you pick values to see where it hits and it goes towards the asymptotes. and you draw it in. And this is just picking a value like x equals 1, x equals 2, seeing where it's going. It gives you a positive or a negative, and you go from there. So on to number 16. We sketch the graph of f of x to the, 4 to the f of x, where it's 4 to the x minus 5. So we need to show any intercepts or asymptotes. Okay, let's see what we can do. Let's try intercepts first. Let's do our y-intercept. So with our y-intercept, our x is equal to 0. That gives us 4 to the 0 minus 5. Okay, so that is, for anything to the 0 is 1. So 1 minus 5, we get that our y-intercept is when it's negative 4. Okay, that we can work with. Now let's do our x-intercept. With our x-intercept, we set it equal to 0 because our y is, when anything hits the x-axis, our y is 0. So we get 4 to the x minus 5. We're going to add 5 to each side, so we get 5 equals 4 to the x. I don't know what this is specifically, but it's somewhere above 1. Because 4 is a little less than 1, and an exponent would need to be a little bit higher than 1. 4 to 1 is square, or is 4. 4 squared is 16, so we're pretty close to 1 point something. So I'm just going to draw these on my graph. I know I have an intercept at 4, negative 4 I mean, and somewhere just above 1. Now I need to know if there are any asymptotes. And so I ask myself, what can I put in this 4 to the x? Can I have anything greater than that? How can that work? What happens is we have an asymptote at negative 5. So we're going to draw that in. Now, why do we have an asymptote at negative 5? Any number that we put in for x, right? This x, let's put in x2, let's put in 2 for x. If x equals 2, we get 16 minus 5, or 11, right? So we know that it's going to be somewhere up here. But what happens if we put a negative number in there? We've got 4 to the negative 2, right? Let's do negative 2 over here. Now we've got to remember that it is an because it's a negative exponent, it's going in the denominator. So we're going to have 1 over 16 as our y minus 5. And that's going to be just above 5. And the higher x value we put in, the closer and the closer. It's going to be like, if we have 1 over 1 million, that's almost 0. So we're never going to hit negative 5, but we're going to get pretty close to it, right? And we know that we're going to have an intercept at 4 and just above 1, and that's our graph. Hope this was helpful, and talk to you again soon. Have fun.